This is DeepMind, the podcast. I'm Hannah Fry, a mathematics professor and your trusty guide to the rapidly evolving field of artificial intelligence. So far in this series, I've spoken to people who are using AI to advance scientific discovery.
You have techniques that can tackle some of the hardest problems that have eluded the brightest minds.
Attempting to solve intelligence. Do people still roll their eyes?
Every year it becomes less.
And using AI for real-world problems like weather forecasting.
The dream here is to warn people before really extreme flooding events.
Each of these tasks is enormous in its own right. But there's a fundamental challenge running in tandem. AI needs to benefit everyone, not just those who build it. DeepMind's mission statement is solving intelligence to advance science and benefit humanity.
We really need to take that mission seriously and to ask questions about, well, what does it mean to say advance science and humanity?
For Shakir Mohamed, a senior research scientist, the only way to live up to that is to create AI that works for all of society.
The last set of people who said they were going to advance science and humanity created colonialism. They created a structure of division in the world. We cannot be complacent about what it means to put forward a mission like that into the world.
This is episode 8, Fair for All. Let's start at the beginning. If the goal is to build AI that's fair for everyone, what does it mean to be fair? You might imagine this is a question with a simple answer. Fairness surely is just about ensuring that one group of people doesn't end up disadvantaged over another. Unfortunately, once you try to put that into practice, it quickly becomes clear that sometimes competing definitions of fairness can contradict one another. Let's take gender as an example. Until a few years ago, if you searched for the word CEO on Google Images,
you'd just get images of all white men CEOs.
This is Sasha Brown from DeepMind's ethics team. She, probably like most people, thinks that an image search showing no credible female CEOs at all is not exactly an example of a nice, fair algorithm.
People then think that a CEO has to be white and male, but also because of the way that the algorithm works, whatever comes up on the top page is more likely to be clicked on and therefore is more likely to stay near the top page. So you're kind of reinforcing this stereotype.
Now, there are a number of ways that a researcher could alter this search algorithm to make it fairer. For example, they could tweak the first page of results to achieve a more even gender balance, 50% female, 50% male, say.
Over 50% of people in the UK are female, but 7% of CEOs in the UK are female. So should you have 7%? It's not a simple question as to like how fair is fair enough.
So if I Google CEO now, I'm looking up now. Oh, okay. Things have changed then because, let's have a look. I would say it's predominantly white male, but on the front row, the third image, there is a white woman and a black man. Actually, there's pretty good representation across the board. There is, I don't know about your image search, but on mine there's hot CEO romantic novels.
Yeah, I've got that.
Ooh, steamy. In this example then, some slightly dodgy romantic fiction aside, the search algorithm is not designed to accurately represent company leaders as they exist, but to convey how they might look if company leaders were more representative of society as a whole. This is an active choice. Sometimes you don't want your algorithms to be a mirror. You want them to reflect a version of the world you'd like to live in rather than the one that you do. Because a very real danger of unfair algorithms is that they can serve to perpetuate stereotypes or biases about certain groups in society, locking us into a cycle that's difficult to break. If you cast your mind back to earlier in the series, you'll remember Lisa Ann Hendricks, a researcher on the language team. While studying for her PhD, Lisa Ann was co-lead author on a rather brilliantly titled paper, Women also snowboard. The study looked at algorithms which automatically generate a caption for a given image. This is a car, this is a dog, that kind of thing. Lisa and her colleagues realised that when these image classifiers were shown images of people snowboarding, they were much more likely to label the person as male, even if the person in the image was in fact female or their gender was unclear. I'm just sort of imagining you in grad school, right? You're sat in front of your computer with loads of pictures of female snowboarders, and it's just labelling them. I mean, was it every single time? Man snowboarding, man on a snowboard jumping?
Not always, but frequently.
The opposite was true for images of people in kitchens, who were more likely to be identified as female. It turned out that the image classifier was focusing not on the person in the image, but on their surroundings, applying a pattern it had picked up from the data that men were more likely to appear in images with snowboards.
When you trained models on this data, it magnified and amplified this bias. And so whereas at train time, maybe you had a skew of 70-30 men, women snowboarding, now at test time, you have 90-10.
What Lisa Ann is referring to is a phenomenon known as bias amplification. Somewhere in the algorithm, for reasons that are hard to pin down, any initial unfairnesses get exacerbated. And those initial biases tend to arise during what's known as train time, when a huge online library of images is manually labelled and categorised by humans.
Humans go onto a crowdsourcing website and write sentences that describe the images. So you had some images where the person was very obscured. It really wasn't clear how anybody would make a judgment on something like gender, and they would just say man because they themselves had a stereotype of who snowboards, which is another place where bias can arise, which is that a lot of times we think that humans are going to give us ground truth. And when you're talking about anything sensitive, it's not always clear what the right way to label something is.
Once they recognised the image classifiers were biased, Lisa Ann and her colleagues shifted the algorithm to focus on the subject of the photograph rather than their surroundings. But the truth is, there are no easy answers here. Debiasing, detoxifying, or weeding out stereotypes from AI systems is much more than just a technical challenge that can be solved with a corrective algorithm. And you won't be surprised to hear that it's not only gender bias that crops up in AI systems, but racial bias too. There are countless examples of image classifiers which completely fail to recognise people from particular racial backgrounds. In 2020, there was an outcry over an AI tool which takes pixelated images and converts them into high-resolution ones. It had been disproportionately trained on images of white faces, a bias it duly demonstrated when it transformed a pixelated image of former US President Barack Obama into a picture of a white man.
Another example that has come up is an AI facial recognition technology incorrectly identified 28 members of the US Congress as people who had been arrested for crime.
This is Obum Ekeke, Global Education Lead.
The first matches were disproportionately people of color. Imagine if such a tool was deployed at scale. It means that black people like me will be walking on the street and maybe suddenly stopped by the police who have identified me through a tool that tells him or her that I'm a criminal.
These kinds of biases are a real concern, particularly when they appear in predictive algorithms, where historical data is analysed and used to predict what will happen in the future. A recent study found that an algorithm used on millions of patients in America to identify which of them were eligible for an advanced healthcare program was biased against African American patients. The algorithm was told how much money had previously been spent on a patient's healthcare expenses and used that to predict their future needs. That idea might make sense on the surface, but the algorithm was found to be disproportionately rejecting black patients from the advanced healthcare program.
the data didn't have to have any information about race in order to have racist outcomes.
Sasha Brown from the ethics team again.
So the algorithm based its decisions and it assigned sort of risk scores to patients on the basis of the total healthcare costs they'd accrued in the year before. And so they assumed that the higher the total healthcare costs, the higher the need of the individual. And they even checked and they found that the average black person in the data set had the same average healthcare cost as the white person in the data set. So they were like, okay, this is fair. But then on closer inspection, they saw that the average black person in the data set had also been sicker than the average white person in the data set. And so actually it was unfair and it was discriminating against black people.
Historic disparities in access to healthcare meant that less money had been spent on black patients with similar needs to white patients. The algorithm falsely concluded that black patients must be healthier than white patients and refused them advanced care.
It's an interesting example because people tend to think, okay, well, we've removed the race bit of the data set and anything that we think is a proxy for that, and so it's not going to cause harm. But actually, if you do systematic reviews of algorithms, you see that in the real world, it is actually having impact where historically underprivileged groups are getting less help as a result of this.
For some, these examples of how AI can discriminate against particular groups are not aberrations, but part of a broader historical trend of how the negative impacts of new technologies are disproportionately felt by society's most marginalised groups.
We know that periods of history have caused harms to specific communities, right? And if we look at modern technology through that lens, we see very similar patterns in certain uses of AI.
William Isaac is a senior research scientist on DeepMind's ethics team. If you listen to Series 1 of this podcast, you might remember William's work on the use of racially biased algorithms in the US criminal justice system. In May last year, William was one of the authors of an influential paper on decolonial AI. Can you give me an example from history where science and technology has been used to exploit marginalised communities?
The most salient one for me is the US public health studies that were done from the 1930s all the way to the 1970s on African-American sharecroppers.
In 1932, scientists began a study of syphilis in Tuskegee, Alabama. At the time, there was no known treatment for the disease. 600 African-American men were recruited for the study in return for free trips to a physician and hot food. Of those, 399 had latent syphilis, but none were told of their diagnosis or what the study was for, only that they had bad blood. Over the following 4 decades, the scientists wanted to study how the untreated disease would evolve. About halfway through the experiment, penicillin became the standard treatment for syphilis. It was almost totally effective against the disease, but the scientists did not offer it to their patients. Even as many of the men went blind or developed severe health problems, the scientists continued their experiment. By the time the story broke in 1972, 28 of the men had died from syphilis, while around 100 others had passed away from related complications.
This is one of the black marks in history in the scientific community, because it not only represented the kind of power imbalance that science can have in communities, but also it eroded trust in the African American community.
For William, a decolonial lens reveals clear parallels between the treatment of black communities by today's biased healthcare algorithms and the medical researchers of 1970s America. Being conscious of these historical parallels is one thing, but decolonial AI urges those involved in designing AI not to repeat the mistakes of the previous technological revolutions.
The decolonization of AI is also a project of hope.
Shakir Mohamed was a co-author of the Decolonial AI paper.
It is a project to say that we can come from a world that was built on slavery and genocide, on exclusion and discrimination, but actually we can try to design a better world. That's my number one hope, that everyone, they don't have a reaction to this word decolonizing, but they actually see that it is asking us to think of a different future than the one we've inherited.
For William and Shakir, building AI that benefits all of society goes beyond fairness in the narrow sense of achieving equal algorithmic outcomes for all groups. It involves thinking hard about where, why, and in which circumstances AI systems are deployed. Take the example of a facial recognition system for entry into an apartment complex where the majority of residents are black. Because facial recognition systems are traditionally less accurate for people of colour, residents suspected that developers were trying to attract more white, higher-income residents into the block. They successfully prevented the facial recognition system from being installed.
And so it's the intentional acts of how we use these systems is also equally as important as whether or not the system meets this goal of having equal performance across groups. So if you just look at the system, whether it's fair or not, you would miss the entire point of where the negative externalities of a system lie.
How long do we have to wait until people stop making the exact same mistake over and over again?
I hope not too long. Even if the first step is like, we don't release systems out into the world that actually impact people until we address the kind of underlying challenge around data, that would be a good first step, right? I know we're not going to solve all the problems with embedded bias in data. I don't think that's an attainable goal, but we can control which ones are released out into the world in high-stakes settings, like whether or not you're going to be able to stay with your kids, or whether or not you're going to have housing, or whether or not you're going to go to jail.
But as the example of the housing project demonstrates, the issues around consent and data privacy are becoming all the more important as AI is increasingly deployed in the real world. And in some cases, the question of what an AI claims to know about you and who it shares that information with can have serious consequences. Take, for example, a notorious paper from Stanford University in 2017, which announced an algorithm that could accurately predict whether someone was gay or straight from a photograph of their face. The algorithm in question had been trained on thousands of pictures of faces from a dating website, together with their sexual preferences, and boasted 81% accuracy in identifying gay men and 74% for gay women. There was just one problem. Trying to determine someone's sexuality from their facial features is what's commonly known as junk science.
It's hard to even know where to begin with that paper.
This is Kevin Mckee, a senior research scientist. We met him in episode 3, where he told us about his algorithm for altruism. Last year, Kevin co-authored a paper about the impact of AI on queer communities.
You could potentially be falling into the trap of thinking that there's some sort of causal link between someone's appearance and the way that they identify. And again, it's leading you down a very dangerous path.
What might seem like a silly gimmick to some people could have grave consequences if it were deployed in some parts of the world. Here's William Isaac again.
There are governments who would likely use a system, even one that was completely inaccurate and just junk, because there's a belief that machine learning systems confer a sense of authority about information and prediction. And this is why these are particularly pernicious systems.
And although these so-called gaydars are fake pseudoscience, there are other ways that an AI tool could genuinely threaten the privacy of LGBTQ+ people.
Every time you like a page or you interact with someone else online, you generate digital traces. The challenge is when you have an algorithm that can kind of sweep over all of those different traces and start to say things about me that I never intended to be public. So if I did not want other people to know that I'm queer, but then someone designs an algorithm that's able to predict that, that's a huge challenge to privacy.
The harms against queer communities, I think, take many different forms today.
Shakir Mohamed is also a co-author on the Fairness for Queer Communities paper.
An everyday experience is being in an airport, and you are in those scanners. One really significant harm to our trans community is that those scanners require the operators to click beforehand, male or female.
What Shakir is referring to here are the full body scanners that use X-rays to look underneath a person's clothes to detect any illicit items. An airport security officer might assume that someone is male, click the corresponding button, at which point the scanner alerts the security guard that this person has something concealed in their chest area. But say this person is undergoing a gender transition. They've been singled out and humiliated by a machine that expects a man's chest to look a certain way.
That is a form of dispossession, and that kind of benign automation is something that really affects people on their day-to-day living experience.
And as much as AI can threaten the privacy of queer people, there are ways in which a carefully designed AI can have a positive impact too. For instance, in March 2021, a charity which supports young LGBTQ+ people in America, known as the Trevor Project, unveiled a chatbot named Riley. Riley simulates a conversation from a young genderqueer person in crisis. The idea is that conversing with Riley can help a volunteer understand how best to respond, honing their skills for the real conversations they'll have when they matter the most. So far in this episode, we've considered how researchers think about ideas of fairness and decolonial AI to ensure that their systems don't discriminate against particular groups. We've also looked at some of the issues that can arise from the deployment of AI systems in the real world. But an important part of ensuring that the benefits of AI spread to everyone is making sure that more diverse groups of people are present in the labs where AI is built.
How you actually get to really safe and robust technologies is you have different lived experiences looking at the same technology from different lenses and are empowered to actually make sure that you live up to the kind of billing of like having technology that is safe, especially when you're working with transformative technologies that will impact billions of people.
And there are no prizes for guessing which groups of people are currently underrepresented in the field of AI.
One way to think of it is how many people are graduating from AI PhD programs.
That's Obum Ekeke again.
In North America, for example, it's estimated that the female graduates of AI PhD programs have accounted for less than 18% of all PhD graduates on average in the last couple of years. As a father of 3 beautiful girls, that gives me a lot of concern. The other group as well that is predominantly underrepresented is Black, people like me, and other minority ethnic groups. Here in the UK, in 2019, Black people made up only 3% of the tech workforce.
Listening to this, you might be wondering about a question that Obum gets asked a lot about the AI industry as a whole.
Why can't we just diversify? That's what every organization should have done from the word go. One of the biggest challenges is recognizing how systemic these issues are.
So is it that there aren't enough people from the underrepresented groups that Obum talks about who are trained in AI to a high level?
There's always an argument in the field around, the pipeline doesn't exist, so you can actually find people to hire and all that. I don't think that's true. Let's get as many people that are already out there. Let's change our recruitment processes and all these things we can do to tap into the untapped talents that already exist out there, but also while acknowledging that there is actually more work that needs to be done to invest in the longer-term pipeline.
People from underrepresented groups often don't make it as far as pursuing PhDs in AI. In fact, they drop out much earlier. Here in the UK, a government study found that female students are much less likely than their male counterparts to study science, technology, engineering, or maths at A-level. Other studies have found that Black students are more likely than other ethnic groups to drop out of these subjects at all stages of their educational career. And while you don't always need a PhD in AI to work in the field, a background in one or more of these subjects is a useful asset for an AI researcher. It's this principle of making people aware of the possibilities of a career in AI that guides DeepMind's own education program.
We've recently launched a program called the DeepMind Academic Fellowship to actually support early career researchers to pursue postdoctoral studies in the field of AI. And then below that, at the postgraduate level, we've created the scholarship program, which provides very generous scholarship to students to pursue master's and PhD degrees in universities.
Obum Ekeke has seen firsthand how the promises of technology can inspire people's careers.
I grew up in a very rural and poor village in Nigeria, and at the time I was in secondary school, there was a boy about my age who went to the city on holidays, and one of the days we were playing, and he said to me he saw this car in the city, and somebody tried to touch the car, and the car started shouting all of a sudden. And he said to me that you could actually go to university and study the thing that made the car to shout. And then he said so many other things. This thing can also help you to cure diseases. Later, I realized that what this boy was talking about was just a remote control, right? So which has nothing to do with computer science. But what that did for me was it actually helped me to be very interested in studying computer science at the time to solve problems that existed in my community.
As an example of the sorts of benefits that AI could bring, Obum told me about a mobile app developed in 2018 by Penn State University in collaboration with Google. The app uses AI to help farmers diagnose diseased cassava crops.
Cassava provides food for over 500,000 Africans daily. My parents used to be peasant farmers, so I used to go to farm a lot. The challenge we had with cassava is that they are mostly affected by viral diseases, which makes them eventually inedible. A group of researchers developed a solution using machine learning that could help farmers better identify and manage the diseases that affect these cassava leaves by just waving their mobile app on the cassava leaf. That's exciting for someone like me, right? Seeing that this kind of solution could be deployed across Africa.
Technology capable of making a profound difference to countless communities already exists, but there is a conspicuous lack of a major AI presence in many countries around the world. This is a fact that hasn't been lost on Shakir Mohamed. In 2016, while attending a prestigious AI conference, he and some fellow South African AI researchers started asking themselves a question.
Why are there no other South Africans at this conference? Why are there no Africans to begin with at this conference? And actually, maybe part of the question is we don't need to see them at these kind of conferences. There may be other new spaces we could create that doesn't need to necessarily always comply with the mold.
It was this germ of an idea that led to Shakir and his fellow researchers creating the Deep Learning Indaba, a non-profit organisation whose stated mission is to strengthen the machine learning and AI community across the continent of Africa. Indaba, which is a Zulu word for a gathering or meeting, has been running for around 5 years and led to some impressive projects. Take, for instance, the Masakane NLP project. The name means "we build together" in Zulu, and began when African researchers recognised that none of the current language models, those gigantic tools powering smart speakers and chatbots, could recognise African languages. One
of the challenges is that there aren't language data sets for many African languages, all 4,000 of them. The diversity of language means that there are very small communities of speakers of those languages.
Local linguists are collaborating with AI researchers to gather oral and written data sets in several African languages, including Swahili.
In Kenya, for example, if AI is going to enter this world of finance, what they call fintech, it matters that that fintech development product for mobile payments is in Swahili. We have serious problems today across so many of our countries, particularly in Southern Africa, related to the HIV pandemic. One solution, as the need for advice for HIV, but other areas of maternal health care, for example, have come on board, is to create these kind of mobile chat healthcare advisory. It matters that that advice comes in the languages that people speak, because the ability to understand the true context matters. It's a different form of representation, which is why the kind of narrow idea of diversity of the workforce is always incomplete.
As we've heard throughout this episode, the challenges of bringing the benefits of AI to all of society are significant. Individual algorithms need to be fair, and AI needs to create local benefits for everyone, not just those who live in countries with a strong research presence. Addressing this problem will require a more diverse workforce, a more democratic spread of AI expertise across the world, and the inclusion of a broader set of perspectives in building products and algorithms.
We have a great deal of power, because we are the ones who decide what the data set is. If we decide to create a different kind of data set, a different kind of prediction gets made. We can humble ourselves as researchers to leave the bubble that we are in and go to different kinds of communities to come together as new kinds of grassroots organizations, and they can create a powerful pressure on the world around us.
Initiatives that DeepMind researchers are working on, from Indaba to the scholarship program, are a start. But no one company can tackle this alone.
We need to partner with other organizations. We need to work with universities. The government has a role to play. We need to work with a cross-section of stakeholders to actually collaboratively make progress.
Ethics has to be the input into what tech we build and not an afterthought. And it needs to be all researchers' responsibility to think about the social impact of their tech. It's not going to happen by default. It's going to take loads and loads of hard work.
I'm excited to see what does technology look like when you have everyone involved in the process. What new ideas do you develop? Because we won't have the same kind of clustering effect of the same 4 or 5 ideas or uses for a technology. They will look different, right? And that's a good thing. And I think ultimately it's a future that I believe we'll get with time.
We'll be looking towards what the future holds in the next and final episode, when I sit down for a rare interview with DeepMind's co-founder and CEO, Demis Hassabis.
The outcome I've always dreamed of is AGI has helped us solve a lot of the big challenges facing society today.
You've been listening to DeepMind, the podcast. I'm Hannah Fry, and the series producer is Dan Hardoon at Whistledown Productions. We'll be back soon.